Okay, I'm going to be converting units of pressure and temperature. Here are the conversion factors. It says 1 ATM is equal to 760 mmHg, which is equal to 101.3 kPAs. Okay, you're going to have to use this T-chart again, which we should be familiar when we converted moles to grams or stoichiometry, or even just moles to moles. Whatever you're given, the number that you want, and just be sure that these two units match. So you're going to continue to use that for all of these right here. Everywhere it says conversion, you're going to use this. So just go ahead and write that down. I'm going to walk you through the first two on the left-hand side. Okay, again, pay attention to how the units must match. These two match. It says convert 0.875 to mmHg. Well, 0.875 was given to us, so it goes on the top left-hand corner. You just follow this pattern. Just copy it. Number given, top left. Whatever you want, top right. Okay? And it says you're converting it to mmHg. So we go back up here to mmHg to look for the conversion number, and that's where that 760 came from. If anything side to side, you multiply. So after you multiply those two, it's going to equal 665, and don't forget what you converted it to, mmHg. Okay, we're going to go to the next one. There are a couple errors though. You are converting it to kPa. kPa, it just says K. And then mmHg, so this needs to be mmHg here. Okay, because again, it was just a typo. The units need to match. You're converting 745 mmHg to kPa. So that was the number you're given, so it went to the top left box. Given, top left. Whatever you want, kPa, goes in the top right-hand box. Where did we get that 101.3? And at the very top, it tells us that 1 ATM equals 760 of this, and 760 of this equals 101.3. Okay, so we are going from mmHg to kPa, and that's why we put the 101.3 there. Anything side by side you multiply, and then you'll divide by the bottom number. So in my calculator, I'm going to type 745 times 101.3, and that gave me a very large number. I will write it down. 754. And then divide by 760. And this gave me and it's kPa because I was converting to kPa. So just remember what you're changing it to. I'll start you off with number 1 over here. You're going to convert these to atmospheres, and that's the ATM. Okay, so number 1. There's not a lot of space, and if you want to make it look nice, you can go ahead and put on an extra sheet of paper. Number I'm given is 340. Okay, and I want ATMs. If this is kPa, no, this has to be kPa. And ATMs, 1 ATM. And I am looking at ATM. And where did I get those numbers? Back at the conversions. Okay, I'm going to scoot the paper over or zoom out actually. And if you look at the top of your paper, 1 ATM is equal to 101.3 kPAs. It's almost as if it were going to say 12 inches is equal to 1 foot. Okay, that's the conversion rate. So over here, that's what it says. 1 ATM is equal to that many kPAs. If I was looking, the next one is mmHg. I'm going to use this. Okay, the 760 number. So going back over here, am I multiplying or dividing? Yep, you're going to divide because it's top to bottom. So you would type in your calculator 1.340 divided by 101.3. I'm going to do the next one. There's not that much space. I'll try to make it nice. They gave me 540. What do I want? ATMs. This has to be mmHg because the units must match. Okay, those always have to match because you're going to cancel them out and ultimately be left with the ATM because that's what you want. So 760. And I got that 760 from the left side of the paper where it tells you the conversions where 1 ATM equals 760 mmHg. And again, those are units of pressure. So you get 540 in your calculator divided by 760. And that's what I got. 0.7105. Did anybody get anything different? No? Okay. I'm going to go ahead and go down to the bottom. Dalton's law of partial pressure. This is just add up all numbers. Okay, you're going to add up the numbers given to get the total pressure. Okay, they're going to give you numbers and then you add them up. I'll show you the example in number 11. A metal tank has 3 gases, oxygen, helium, nitrogen. And the pressures of those, 35 for oxygen, 5 for nitrogen, and 25 for helium. Then it says, what is the total? To get the total, you just add them up. Okay, that's how you do that one. Well, I'll go ahead and start you off on number 1 in case you feel a little intimidated from reading a word problem. So if you flip the paper over, Dalton's law of partial pressure. When you see Dalton, it's going to be the easiest problem we have in all the gas laws. Dalton, think of adding. Number 1, what is the atmospheric pressure? So you're just going to add them up. I can already see the challenging part is because you're going to have to convert, okay? Because they're giving you the gases in mmHg. It's not a big deal. First, let's find the total pressure. What is the atmospheric pressure if? I'm going to get the total pressure in mmHg and then convert the mmHg to ATMs, the atmospheric pressure, because that's what it's asking for. So it's not a lot of space. Add them all up. This gives me 767.8 mmHg. Okay, but it doesn't want it in mmHg. You have to go ahead and do the T-chart. What number was I given? That's the number I just added. mmHg. Okay, if this is mmHg, what does this unit have to be? They have to match. Okay. What do I want? ATMs. Okay, so I'm going to flip the page to go back to all the conversions to see what numbers to plug in. How many mmHgs give me one ATM? 760 give me one ATM. That's the conversion factor. 760 give me one. So, in order to get that one ATM that I just put right here, it's 760. So, top to bottom, do I multiply or divide? Divide. And that's a little division symbol. So 767.8 divided by 760. There's not a lot of room. That is the total pressure of whatever this is, this cylinder. It's right there at the very top. Okay, so through this video you should learn how to convert, okay, using the T chart, practice doing those, and then Dalton's formula, which is adding up all the partial pressures in order to get the total pressure.